All right, we're going to look at finding the rational roots of this equation, the question that you had asked about. To do this, we use a method called P over Q. And typically we'll write that as P over Q. The question is, where do I get the P's from? Where do I get the Q's from? Well, what we look at is we look at two particular parts of this equation. The first is the constant P. And in this case, that's the -7. And what we want to list are what are all the factors that when I multiply together will give me -7. And there's only two that I can think of, two combinations. One is I could take +1 times -7. Or the other possibility is I could take -1 times +7. How we would typically keep track of those is I would say, well, my two factors are I've got a plus or a -1, and I've got a plus or a -7. Those are the combinations that when I multiply would get me to that -7. The second thing we look for are the factors of what we call the leading coefficients. So we go to the exponent of the x with the highest degree, which in this case would be the 4, and I look at the 28, and I do the exact same thing. What are my factors that would give me a positive 28? Well, I know that 1 times 28 will work, so I know I'd have a 1 and a 28. I also know that 2 times 14 would work, and I also know that 4 times 7 would work. Those are all the positive ones. I could also change all those to negatives. -1 times -28, -2 times -14, -4 times -7. So I would list those as plus or -1, plus or -2, plus or -4, plus or -7, plus or -14, and plus or -28. Those are all the factors that would give me a positive 28. Now what we do for our P over Q is I will take each of these P factors and I'll put them over each of these Q factors. And so what it will look like is this. If I take 1 over 1, 1 over 1 would just give me 1. And it doesn't matter. If I take +1 over +1, I'd get 1. If I take -1 over +1, I'd get -1. If I take -1 over -1, I'll get +1, and so forth and so on. So what we typically do is we just say, well, that's plus or minus. Then I'd put the 1 over the 2. Same idea, it'd be a plus or a minus. And I'd get 1 over the 2, 1/2. Then I'd put it over the 4, so I get plus or minus 1/4. Then I put it over the 7, plus or minus 1/7. Over the 14, plus or minus 1/14, and over the 28, plus or minus 1/28. Now you might think, wow, this is going to be a huge process. Well, as I start to get to the next numbers, look what happens. Now I'm going to put 7 over everything. 7 over 1, well, that's plus or minus 7. 7 over 2, plus or minus 7/2. 7 over 4, plus or minus 7/4. You think, well, how is this shortening up anything? Yeah, but watch out. It's plus or minus 7 over 7. Isn't that going to take me back to my 1? I already have that. Plus or minus 7 over 14. That's 1/2. Oh, I already have that. Plus or minus 7 over 28. I already have that. That's 1/4. So these are all the potential possibilities. Now, it's not to say that all of these will work, because we know that from what we've learned in previous problems, I'm only going to have a total of 4 solutions. The highest power tells me how many solutions I'm going to get. In this case, there's only 4 solutions that I'll be dealing with. What I have to do is figure out which one of these 4 will work. All right, now to do that, how I'll set it up is I'll use something called synthetic division. Let me see if I can clean up our screen here a little bit for us. So how I'm going to set this up is in my little box. We're going to use synthetic division. I'm going to put all the numbers. And what I have to do now is I have to go back and write down the coefficients of all the numbers that I've just worked with. Those coefficients are the first one was 28. That was to the x to the fourth. Then I had a 164. That was my x cubed. Then I had a negative 213. That was my x squared. Then I had a 76. And finally a negative 7. Now I'm kind of doing this with you as we go. I'm not going to try and jump way ahead and get to the answer. I'm going to try and plug them in just the way I would do it if I were working this particular problem. So what I try first is I might try a number like positive 1. And so I'd put a 1 in the box right here. We know that in synthetic division, this number comes down first, so that's the 28. That comes down. We multiply these two together. That gives us a positive 28. Add. That gives me a 12, carry a 1, 9, 192. Multiply, so I get 192. Add. In this case, I'll get a negative 21. Multiply, I'll get negative 21. Add will give me a positive 55. Multiply, I get 55. Add, I get 48. Did not turn out to be 0. So what we know is that 1 is not one of the factors that works. Now with my marker board, it's a little bit easier, because what I can do is I can go through and I can erase all those that I don't want. I don't want this, 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 or this. That's not going to be there. And then I can get rid of the 55, the 21, this, and this, and I'll try again. Before I throw away that 1, I'm going to try negative 1. See where that gets me. That will give me a negative 28. Add, and I'll get 6, 136. Multiply, I get negative 136. And I think we can pretty much see at this point it's just going to keep getting bigger. There's no way that I'm going to get it to work out to be all this other stuff that I'd like it to be. So what I can do at this point is just stop. I know negative 1's not going to work, so I'll throw negative 1 out. I'll erase these numbers, and now I'll go through to the next. Now you might have a pretty good idea of what you think the numbers are going to be, so you might skip and jump to a specific point to try and find the next number that potentially would work. Maybe that's a number like, well, we'll try it. What if it was 1/2? Multiply, I get 14. Add, I get 178. Multiply, and I will end up with, what would that be, 89. Add, and I'll get negative, let's see, 124. Multiply, and I'll get a positive, or excuse me, a negative 62. Add, and I get 14. Multiply, I get 7. Add, I get 0. So we know that one of our answers from this is 1/2. So I found one of them. So I'll put that kind of off to the side down here. We know that 1/2 is going to work. Now the nice thing about this is I now know that I can drop down to my next polynomial. This is what we call the depressed polynomial. And I know that as I look at each one of these, that the good news about each one of these is I'm going to do this whole process over again, but I'm going to do it with these numbers here instead of going back up to the bigger numbers and starting all over again. One of the things I also know is, as I'm looking at this, I notice that 14, 124, 178, and 28 are all divisible by 14. So what I'm going to do is I'm going to divide each of those by 2 so I can have some smaller numbers. So I'm going to take this whole row, divide it by 2. So the new numbers that I'm going to work with are 14. Half of this is 89. Half of this is negative 62. Half of this is 7. And that's now where I will work my synthetic division a second time. And I will try numbers again. We know for sure the 14 is going to come down. Let me move this up a little bit. We know for sure the 14 is going to come down. And now we'll try again and run through some numbers. Now, it could be that I would go through and try those exact same numbers over again. Although, once I know that one doesn't work, I know the other ones won't work either. So I'm not going to try putting 1 in there again. I could, however, find that 1/2 works again. So I'm going to start with my 1/2 and just happen to see if it's in there twice. Multiply, I would get 7. Add, and I would get 96. Multiply, and I would get, what is that, 48. Add, I get negative 14. Multiply, I get negative 7. Add, I get 0. So it turns out in this case that that 1/2 happened a second time. Now you can list it twice, or oftentimes we'll write this as a double root, a DR. Good news is I'm down to these numbers right here, and if you'll notice, all of those numbers are divisible by 14, I believe. So as I go through and try and simplify these, I'll get the following answers. Oh. Wait, let's back up. I don't think 96 is divisible by 14. Looks like it might only be divisible by 7. So we'll have to fix that. We don't want to divide by 14. In fact, we're only going to divide by 2. Let's just divide by 2 to start with. So that'll take me down to at least a little bit smaller number. So that'll give me 7. This will give me 48. This will also give me a negative 7. All right. At this point, I can continue the process if I want to. Use my synthetic division again. We know it's going to be right here. Much smaller numbers. We know that this is going to come down as a 7. The other option I have is I can go through and use my depressed polynomial, which now leaves me with a 7x squared plus 48x minus 7. I could look to see about factoring that. Well, I think I'm going to jump ahead here. I'm going to jump up to 1/7. You might say, well, why are you jumping up to 1/7? Well, kind of notice something about this. This times this will give me a 1. Add, I get 49. Multiply this times this, and I actually end up with 7, which gives me 0 for an answer. So I know that 1/7 is going to be an answer. And now looking for a fourth answer. Notice what I'm left with. This equation that I'm left with, if I can pull this off to the side here for you to see it, leaves me with 7x plus 49 equals 0. Wrap over the 49, I get 7x is going to equal a negative 49. Divide by 7, I get x equals a negative 7, which tells me that my other answer would have been negative 7. And right there are my 4 answers to this particular equation using the P over Q method.